starting streaming. And we are live. This should work. Let's check once again. Yeah, okay, yeah. So this kind of, I'm saving this on a playlist that is actually called Writing an OS in Rust. So as I began, let's open up a console because you need to open up a console. Wait, so it began by actually doing that Phil Engelberg. That's probably not his name. A bit wrong. Phil something. So it started with a tutorial. Building an operating system in Rust, right? And then I had a dependency problem. The boot image didn't work, and I looked online, and there were also other people. So there was, I think, in GitHub, I read it. There was a GitHub issue opened about that. But then somebody on the stream said, you know, like, LOL, you should first learn Rust, right? Even though I find it interesting to learn Rust at the same time while building an operating system. Now, I was doing the Rust by example, and those were the last two videos. And then I got to a certain part, and it just Rust by example, kind of, it would be a very hard tutorial, even though it starts like with, as I was describing last time, it starts with kind of placeholders and how you put inside the variables. But there are also a lot of details that are said, and it basically looks like a tutorial for someone who already, well, I guess that word by example, you know, it's just the tutorial is, yeah, I wouldn't recommend it for someone, you know. I wouldn't, what I mean is I would recommend it, right? But maybe after you've done some Rust, or maybe if you're coming from a different, let's say you had an experience in C, for example, writing something like this, right? Something low level, so you're familiar with the imperative programming, maybe then it would make more sense. For me, as someone who only had experience in functional programming, I'm still, this is kind of, well, not so much experience, but that's what I was trying to learn, Haskell and Nix. So then it was recommended that I on the stream, which is really great. I just want to say also streaming on Twitch, since I've never streamed before on Twitch, is really nice. So it's very, it's a different kind of a vibe than when you are alone. So there are like 3 levels. The first level is you learn on your own. The second level is you stream about it, which I think is great. You stream about it. No, actually the second A level would be you record yourself, right? And you upload that. But once you start to stream, it's kind of a different kind of a vibe, because, you know, someone can come and it's like you can't hit a pause button, right? And those little things really change the way you learn. So I really like this, and the Twitch is somehow it was very nice. All right, so anyway, I'm gonna start now with the Rust programming, with the Rust book. Now I'm still kind of, how do I feel? Well, I kind of miss Haskell, trying to learn Haskell, but I really want to, I really want to do this. So I'm gonna go now. I just got here. I'm gonna start with the Rust book. Now I'm gonna read through this book, and this will not be a reading like, you know, reading every sentence of sorts. Maybe some things I'll skip, and maybe I will spend more time playing with certain parts. I'll see how, you know, I progress and what kind of, you know, hiccups or something I, you know, stumble upon. So first things first, getting started. All right, so installing Rust. I'm on Nixos and I already have Rust. I've basically, I haven't really, I guess there are also good ways to set it up, but I basically just, added it to my configuration.nix. But Rust, I was on Void a couple of days ago, and it's really not hard to install Rust. You just go to Rust page, and there's this curl script that you download with curl. And then, okay, so now we're going to do and write our hello world installing Rust, writing a program that prints hello world, and using Cargo. Cargo, Rust is package manager and build system. All right. So install Rust. These are command line notation. This is the link. You install that. Rust is now installed. Great. This is instruction for Mac. Installing Rust up on Windows. Rust C version. Let's check. Rust C version 1.820. And there is some kind of a code here. I'm curious. What's this code in the Rust version? Yeah, I don't know if my ChatGPT will work now. I haven't paid now. I have premium, but it expired today. The output from Rust C versions such as Rust C 1.82, information about the version of the Rust compiler. So Rust C is the Rust compiler itself, 1.82, version number of Rust. It follows semantic versioning, which typically uses a format like major, minor, patch. So the major, minor 82, and patch. I'm still not clear what's the difference between the usual way. Semver. 1 is the major version of Rust, 82 is the minor, indicating new features or updates that don't break backwards compatibility. 0 is the patch version for bug fixes. I guess so it's not about that old one, like 1 is the unstable and 2 is the stable. Maybe that's the difference, right? I kind of remember that. So 182 means it's Rust's first major, 82nd minor update, and the 0th patch for that minor version. All right. Yeah, I was wondering about this number. This is the commit hash. It's a hash. Yeah, this is the commit hash of the specific source code commit used to build this version of Rust. It's a unique identifier from Git, Rust's version control system that points to the exact code snapshot used. 2024 10.5 release date. All right. So semantic versioning. This is a little bit about semantic versioning. Semver. Initial development. Okay. Yeah. In Windows, PowerShell, updating, uninstalling, local documentation. So I guess there is a local copy of this book with run rustdoc, rust.doc. Time to write your first Rust program, traditional when learning a new language. Yeah, it's a hello world. So we'll do the same here. This book assumes basic familiarity with the command line, makes no specific demands about your editing or tooling or where your code lives. So if you prefer to use an integrated development, all right. Let's do for Linux, Mac, enter this. So it wants us immediately to create. Well, let's do this. Where am I? I'll go to code and go to Rust. What do I have? Do I have Rust? CD Rust. So I'll create projects. It's telling me to do it in the home directory with projects. Why with projects? All right, let's do it inside of Rust. mkdir projects. Well, it's a Rust book. I'll do a Rust book, CD Rust book, CD Rust book, and do I do projects or CD projects? Hello world. Okay, projects. I don't like this title now. Okay, so we do MKD or hello world. Okay, another hello. Wait, this is too much. Too many directories. Wait, code Rust book. Let's do just hello world, right? Hello, and it's a snake case, right? I'm used to camel case from functional programming. Is it a camel case? Yeah, camel case. No, wait a second. Why am I confused? It's so weird. All right, and go to hello world. And writing and running a Rust program. Now make a new source file, call it main.rs. I'm going to use Helix, and we're going to call it main.rs, right? Rust always ends with the rs extension. The convention is to use an underscore to separate them if you're using more than one word. So that's the snake case, I guess. That's what they call the snake case, right? So you can do like snake, I guess, snake case and camel case, right? Something like that. Camel case, snake case. Yeah, anyway. Now open the main.rs you just created and enter the code file name main.rs. And we're going to write it fn main. So this is our main function. And the main function has no arguments or parameters. And we're going to open up the body of the function. So the body of the function will be, I like to start, wait a second. I'm going to do this here too, like in Haskell, right? We have now a working program, right? So if I run this Rust C, is it Rust C? Yeah, Rust C main.rs, command succeeded. Did I write this? Main.rs written, sh. With sh I can run the terminal commands. So sh rust c main rs, command succeeded. It does tell us this command is succeeded. If I go out and do rust c main rs, it does output something, right? And if you go file type, do I have file or file? No, the program file is not in your path. It is provided by several. I don't have a file. Nix shell file. File main. ELF 64-bit LSB Pi executable, dynamically linked interpreter, debugging from not stripped. All right. So let's go back to our main rs, right? No. hx main rs. And we are going to... sorry. I still haven't really learned. Anyway, fn main println hello world, right? And it ends with a semicolon because it's a statement, right? And if I do fa, if I save it and do now sh, we're going to do rust c, so we call the compiler and it compiles the main rs, command succeeded. Oh, I can print it here actually, sh main like this, and we have a hello world. So I guess we can do more of those, right? Println hello Twitch, right? Hello Twitch. So rust c main rs and sh main hello world, hello Twitch. Why is hello yellow? and the world is white. Maybe that's something with how Helix does this, because otherwise we won't see it, I think. Yeah, hello world, hello Twitch. So save the file. Okay, this is all okay. Troubleshooting. You've originally written a Rust program that makes you a Rust programmer. Welcome. Anatomy of a Rust program. Let's review. So now comes the review, and now comes the empty function, right? And you can press play here. No output. Yeah, these lines define a function named main. The main function is special. It's always the first code that runs in every executable. The first line declares a function named main. No parameters, returns nothing. If there were parameters, they would go inside the parentheses. Yeah, that's like... but yeah, I'm thinking now in next terms, like... wait. fn main is the argument list. That's the name of the function, main. Yeah, I was just thinking something. I was thinking like in Nix REPL, like in Nix REPL you see this, and this is a lambda, and I pass it a 2 and I get a 2. So the main function would be like main is, how would you call it? Main is x and x. I guess this, would this work? And then main, right? And if I do main 2, I get 2. I don't know, would that be, yeah, anyway. So these lines define a function named main. The main function is special, always the first code that runs. The first line declares a function named main that has no parameters and returns nothing. Maybe this is too distracting. The music. If there were parameters, they would go inside the parentheses. The function body is wrapped in curly braces. So the parameters are always in the parentheses. Parameters, parentheses. So the function body is wrapped in curly braces. It's funny, I know there is a difference when I was learning Haskell, like, do you call them arguments or parameters? So the arguments, I think the arguments, yeah, I forgot what's the difference between arguments. I'm not sure what's the, in Rust, is it, do you say arguments or parameters? There is a difference. The terms arguments and parameters are used similarly to how they're defined in most programming languages. Parameters refer to the variables in the function definition itself, acting as placeholders for the values the function will receive, and arguments refer to the actual values passed to a function when it is called. Oh, so it's like the parameter is the x, and the value that you pass to the x is the argument. So the argument is the value, and the placeholder is the parameter. Yeah, okay, that's the difference. The first line declares a function named main that has no parameters and returns nothing. If there were parameters, then we would pass them the value, right, as an argument, and they would go inside the parentheses. That's not written here, I just said that. The function body is wrapped in curly braces. Rust requires braces. These are brackets. I was calling them braces. Rust requires curly brackets around all function bodies. It's good style to place the opening curly brackets on the same line, alright, adding one space in between. If you want to stick to a standard style across Rust projects, you can use an automatic formatter called rustfmt to format your code in a particular style. I guess we don't have to do that yet. You know, the Rust team has included this tool with the standard Rust distribution. So maybe I can just, run it. So Rust C, so it should already be installed in your computer. So the body of the main function holds the following code. This line, so that's hello world. This line does all the work. It prints text to screen. There are 4 important details. 4 details. What are the 4 details? Rust style is to indent with 4 spaces, not a tab. All right, I'm not sure if I have that set up in Helix. Maybe I should do that so that when I press, I don't have to press space so many times. Should I do that now? Maybe not. I guess I won't be typing so much. But okay, 4 spaces, not a tab. Second, print line calls a Rust macro. If it had called a function instead, it would be entered as print line. Now, I guess I could try this. Will this work? Will this work like this? Rust C main rs. No, expected function found macro print line. Help use to invoke the macro. Aborting due to one previous error. For more information about this error, try Rust C explain EO423. That's nice that you get this Rust C explain EO423. So it's common to forget the trailing exclamation mark on macro invocation, which would also yield this error, print line. This is the error. Another case where this error is omitted is when a value is expected but something else is found. Yeah. A value is expected, something else is found. This is kind of a imperative language that I'm getting used to, and that I still have a certain kind of I think version would be too strong of a word, but more like uncomfortableness, uncomfort-like vibe, because it's very imperative. There are these things called lifetimes in Rust, but as always, a lifetime sounds like a word or like an abstraction that ends at that word. Like, it won't, like in, Haskell, you have a sort of an abstraction, and it's possible to go up scale-wise with abstractions. But how do you abstract a lifetime? Anyway, I'm getting off topic. So 4 things we were saying. So first thing, indent 4 spaces. Second, print line exclamation calls a Rust macro. Right. If it had called a function instead, it would be entered as print line without the exclamation mark. We'll discuss Rust macros in more detail. For now, you just need to know that using a exclamation means that you're calling a macro instead of a normal function, and that macros don't always follow the same rules as functions. Third, you see the hello world string. We pass this string as an argument to print line, and the print line is printed to the screen. Right. Oh, so we can see something like main has an empty parameter, like a list with no arguments, and the body of the main function is a macro that does have the parameters, well, the arguments are already supplied as a value, right? So we have like a macro within a function. This is a function main that calls a macro, that calls the print line that prints this, and we pass to this kind of list. Is this a list or what? The list, the parameter list. Hello world. Yeah, I guess maybe, yeah, I guess hello world. If we make this more abstract, hello, like this, hello world, and we do hello and world. Will this leave the spaces like this? Now if I will this print Rust C? No. Expected function found macro. Wait, did I fix that? No, I didn't. Yeah, we didn't fix this. Okay. So if I go and quit, right, and I go Rust C main RS, it does work. So we get a hello world. You see this is a placeholder and a placeholder. So I guess now you can say this is a list of parameters, a list of, I'm not sure, it may not be the right term. So, but anyway, this is a parameter and the second parameter, and we pass in the value as an argument. And the argument is hello and the world. Yeah, I'm sorry, like maybe I'm going too much about this, but I think it's important, especially in first steps, that you get the movement of how the code evaluates, I guess. But anyway, I'll continue. Second, print line calls a Rust macro, right? Third, you see the hello world string. We pass this string as an argument to print line, and the string is printed to the screen. We pass the string. Yeah. Fourth, we end the line with a semicolon, which indicates that this expression is over and the next one is ready to begin. Most lines are Rust code and with a semicolon. That's the another thing I'm not too crazy about also in Nix. Because what's the abstraction like? It's a statement and it ends with a semicolon, right? The expression is over. Yeah, okay. Compiling and running are separate steps. You've just run a newly created program, so let's examine each step in the process. Before running a Rust program, you must compile it using the Rust compiler by entering the Rust C command, right? We did this, main name of the file. If you have a C or C++ background, you'll notice that this is similar to GCC or CLang or Clang. After compiling successfully, Rust outputs a binary executable. Linux, Mac OS, and PowerShell on Windows, you can see the executable by entering the ls command in your shell. Rust by example. Actually, I should rename the it's not Rust by example. This is the Rust book, the book of Rust. So this would be now the first one, actually, the Rust book. Okay, we're going to the Rust book, right? I'll just change, right? Okay. On Linux, you see two files, right? If you're more familiar with the dynamic language, you might not be used to compiling and running, all right? So Rust is an ahead of time compiled language, meaning you can compile a program and give the executable to someone else and they can run it even without having Rust installed. Okay, if you give someone a Ruby Python They need to have Ruby, Python, or JavaScript, right? Right, that's okay. Hello Cargo. So this is a Rasta's build system and package manager. Most Rastaceans use this tool to manage their Rust projects because Cargo handles a lot of tasks for you. The simplest Rust programs like the one we've written so far don't have any dependencies. If we had built a Hello World project with Cargo, it would only use the part of Cargo that handles building the code. As you write more complex Rust programs, you'll add dependencies. Right, because the vast majority of Rust projects use Cargo, the rest of this book assumes that you're using Cargo too. Cargo comes installed with Rust if you use the official installers discussed in the installation section. So we also have Cargo installed. Right, if I do Cargo version, also the same. Okay, if you see a version number, right, creating a project with Cargo. So it says to let's create a new project using Cargo and look at how it differs from our original Hello World. Navigate back to your projects, then on any operating system run the following. So let's do Cargo new, and we are going to name it Hello World. Snake Hello Cargo. So now we have a directory, Hello Cargo. Are we inside of Hello World? Oh, let's remove this actually. How do I remove it? I could just delete it, right? But is there a cleaner command to remove? Is there cleaner command to remove a cargo directory than just rmfrf? Oh, yeah, I'm a little bit tired. It's late. It's not so late, but it's been a long day. Yeah, it's been a long day. Use Cargo's built-in clean command. Cargo clean removes the target directory. Retrash my project directory. What do you mean? Just trash? Install trash. No, I don't want. I'm just asking. No, I'm just asking. Cargo clean what? So like cargo clean directory name. I've just watched the Joker movie, the new one. It was very nice. Very sad at the end, actually. I mean, the whole film is like kind of sad, but very nice vibe. Unfortunately, Cargo Clean doesn't support specifying a different project directly, so you have to navigate to that project or manually remove its target. Right, so you can. I'll just rmrf hello cargo and it's gone, right? We'll go one step up to projects. What did I do here? I don't have tree, great. Rust book. I don't know. I'll just create here. Wait, it said navigate back to your projects directory or wherever you decide to store. Cargo new hello cargo. Oh, all right. I'll remove projects actually. I'll just keep the hello world and do cargo new hello cargo. And I go to cd hello, right? So what do we get? Cargo, toml, and source, right? And if I go to source, and we have a main, print hello world, right? So the first command creates a new directory and project. This is all kind of going to hello cargo. You'll see cargo has generated 2 files in one directory, cargo toml, and a source directory with a main rs file inside. It has also initialized a new git repository along with a git ignore. Git files won't be generated if you run cargo new within an existing git. You can override this behavior by using cargo new vcs git cargo toml in your text editor should look similar to the code enlisting file name hello cargo. So now it wants us actually to main rs. Let's go to cargo toml. It's already written 2021 edition. Oh, we have the same edition. Version, hello cargo, dependencies. See more keys, right. Tom's obvious minimal language. Yeah, I wonder if you... Yeah, I was just thinking like, could you do this in Nix? The next 3 lines set the configuration information cargo needs to compile your program, the name, the version, and the edition of Rust to use. We'll talk about the edition key in the appendix. The last line is the start of a section for you to list any of your project's dependencies in Rust. Packages of code are referred to as crates. We won't need any crates for this project, but we will in the first project in Champer 2, so we'll use this dependencies section then. Okay, open source main rs and take a look. Yeah, generated a hello world. So the difference is that cargo plays the code in the source directory and we have a cargo toml configuration file in the top directory. That's the difference what cargo does. So source directory, and in the top directory we have a cargo toml. Cargo expects your source files to live inside the source directory. The top level project directory is just for README files, license information, configuration files, and anything else not related to your code. Using cargo helps you organize your projects. There's a place for everything and everything is in its place. Now let's look at what's different when we build and run the Hello World program with cargo. From your Hello Cargo directory, build your projects by entering the following command. So now from your Hello Cargo directory, so I guess we stay here and we do cargo build. Yeah, I need to wait. Yeah, all right, let's see. Cargo build. What do we get? Cargo lock, cargo TOML, source and target. So if we go to the target, cache dir tag and debug. Cache dir tag. This file is a cache directory tag created by cargo. All right, there is a debug. That's why it's nice to have niche, the tree. Let's do it with tree. Now we can see with trees, 10 directories, 18 files. Cargo lock, cargo TOML, source, main RS, target, debug, build and deps, examples. There's more examples. Hello cargo D, incremental. Oh, these are like the linker files, I guess. Bin, oh, I know from C, like with O, these are linker files. So the files in between, like between the source code and the compiled executable. Query cache, work products. Really? So like if I go to bat, target, incremental, no, what's the directory? Target, debug, incremental. Incremental. Hello S. Five, no. M, what is it? M lock dash, right. And then let's try RGO. No. 4. Binary. File target. Yeah, I don't. Maybe that's too much for now. A master. So it's already Git init. Yeah, it's like a Git repository. All right. This command creates an executable file in target debug hello cargo. Because the default build is a debug build, cargo puts the binary in a directory named debug. You can run the executable with this command. Target debug hello cargo. Oh. So target debug hello cargo. I see. That's how you run it. If all goes well, hello world should print to the terminal. Running cargo build for the first time also causes cargo to create a new file at the top level, cargo lock. This file keeps track of the exact versions of dependencies in your project. The lock file, yeah, it's like flake lock. I don't know much about flakes, but I don't have flakes. I had them enabled once, but flakes have a lock file, I guess, and you kind of, I guess the idea is similar. So you track the exact things you need to build your projects, right? Version numbers, so that way you can, I guess you can share it or rebuild it when you do need it. This project doesn't have dependencies, so the file is a bit sparse. Yeah, we just built a project with cargo build and ran it with OK, but we can also use cargo run to compile the code and then run the resultant executable all in one command. So we do cargo run. Yeah. Using cargo run is more convenient than having to remember to run cargo build and then use the whole path to the binary. So most developers use cargo run. So notice that this time we didn't see output indicating that cargo was compiling hello cargo. All right, cargo run, cargo check. What's the cargo check? Yeah, I guess you can cargo new, cargo build, cargo run, cargo check. Yeah, I don't want to spend too much time now learning about cargo. Advantage, no matter which, is that the commands are the same no matter which operating system you're working on. All right, building for release. When your project is finally ready for release, you can use cargo build release to compile it with optimizations. This command will create an executable in target release instead of target debug. The optimizations make your Rust code run faster by turning them on, lengthens the time it takes for your program to compile. Okay, this is why there are two different profiles, one for development, when you want to rebuild quickly and often, and another for building the final program you'll give to a user that won't be rebuilt repeatedly and that will run as fast as possible. Yeah, okay, that's kind of nice. Cargo as convention. With simple projects, cargo doesn't provide a lot of value over just using Rust-C. Okay, even though the Hello Cargo project is simple, it now uses much of the real tooling you'll use in the rest of your Rust career. In fact, to work on any existing projects, you can use the following commands to check out the code using git, change to that project's directory, and build git clone. Okay, git clone, example org some project, cd some project, cargo build. Okay, summary, you're already off to a great start on your Rust journey. We learned this and that, and this is a great time to build a more substantial program to get used to reading and writing Rust code. Yeah, please. So in chapter 2, we'll build a guessing game. If you would rather start by learning how common programming concepts work in Rust, see chapter 3 and then return to chapter 2. Let's build a game. So let's jump into Raspberry Working 3 hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in real program. You'll learn about lat, match, methods, associated functions, external crates, and more. In the following chapters, we'll explore these ideas in more detail. In this chapter, you'll just practice the fundamentals. So, a classic beginner programming problem, a guessing game, yeah. Maybe we could improve it. I know that was in the Land of Lisp. Gosh, I bought that book. I don't have it now anymore. Land of Lisp. Totally forgot about that book. Had a great cover also. Wow. I bought this book 2011. Yeah, the Land of Lisp. What a cute thing. I've never went through this book. Maybe I should. Going beyond basic lists, this ain't your daddy's Wumpus. It's a really funny book. I'm getting this vibe now. I want to do something with Lisp also, because I always liked it. And I bought this book 15 years ago, almost. 13. Wow, I really liked Lisp at that time. I kind of just liked it, and read about it. It was really cute. There was a nice video, The Land of Lisp. Will this thing play? Yeah, this. Guess my computer is slow.
A long time ago, a young Lisper was reading an 80s games magazine. The kind with code for basic games printed in it. And he thought to himself, what would be awesome? A book with game code in it, just like this, but which teaches all the important concepts of Lisp programming.
Yeah.
It would use the granddaddy of the Lisp languages, Common Lisp, but would teach...
Did he write something new? Why Lisp is the language of legends? Wow. Yeah. Conrad Barsky. Is that him? No. Is that him actually? But doing Zig? I have no idea. Yeah, okay. This was a bit of a sidetrack, but okay. So anyway, the first project in that book was a guessing game. So here's how it works. Let's see if it's the same one. I think this is a fun thing, yeah. So the program will generate, right, a random integer, which is just a random number, right? An integer is just a type of a number between 1 to 100. It will then prompt the player. It will then prompt the player to enter a guess. After a guess is entered, the program will indicate whether the guess is too low or too high. If the guess is correct, the game will print a congratulatory message and exit. So this is already, we have to create an algorithm of sorts. So after a guess is entered, the program will indicate whether the guess is too low or too high. So I guess it has to compare it. Yeah, you're not sure how will it work. Wait a second. To set a new project, we go to projects directory that you created in chapter 1 and make a new project using cargo like so. Cargo new guessing game. All right. Where are we now? No, let's go up. Hello cargo, hello world. So cargo new guessing game. Cargo new and guessing game. Right, let's go inside. And we are inside. CD guessing game. So the first command in cargo new takes the name of the project, guessing game, as the first argument. The second command changes to the new projects directory, alright? It says to look at the cargo toml. Why? See more keys, right? We just to look at it. Okay, I'm looking at it. As you saw in chapter 1, Cargo New generates a Hello World program for you. Check out the source main RS. Yeah, that's the Hello World. Now let's compile this Hello World program and run it in the same step using the cargo run command. So it just wants us to do... Okay, it works. Target debug guessing game, hello run. So the run command comes in handy when you need to rapidly iterate on a project. As we'll do in this game, quickly testing each iteration before moving on to the next one. I guess the run is some type of a... It's not an interpreter, but it's the closest thing we have to having one. Reopen the source main RS file. You'll be writing all the code in this file. All right. So let's open up the source finally. And let's see. So file name source main RS and use standard input output. Right. Because we will have to input the number. I guess this is the reason, right? So we're going to use standard input output IO, right? Use standard IO because we're going to need to input a number. So fn main. Now we're going, let's delete this and right, 1 second. All right. So fn main. So I guess it starts with guess the number. The computer will ask us print line and guess the number. Right. You can even, we could even like iterate like this. Will this work? Rust C cargo run. It works. Guess the number. Even though probably it complains because we are using stdio and we don't really need it yet. Guess the number. Print line again, please input your guess. All right. Like this. Print ln, please. Comma, I guess. No, it's not comma. Please input your. I thought you put, comma after please. Grr, it's your guess. Please input your guess. Right. Let's do the same thing with this. sh cargo run. Guess the number. Please input your guess. So now we're going to declare some variables. We're going to assign something to the guess, right? So let mut means it's mutable, and the guess will be I guess the name of our variable. And now we're gonna declare, I think this is like we're just gonna put what kind of a, why is it written struct? So it's going to be a string. This means that the guess, oh, I thought the guess will take a number, but it takes a string. Really? Yeah, that's interesting. So guess string is a type of a new, yeah, I'm just like trying to read this like Haskell, but it's not. String has a type. Like when I see this, these two columns, I see has a type. That's in Haskell, right? Like in Haskell it will be f has a type a, or like a bool has a type bool. So what does this mean? String, yeah, okay, well, let's see it explained. Let mut guess string name. All right. And now we're gonna we're calling again io std standard input output. No, standard input. Now we're calling the standard input io. Oh, I guess use standard io and then io standard input. So there's standard in, I guess, and standard out. io standard in. Yeah, these are the tabs and spaces. So I should do like 1, 2, 3, 4. All right, yeah. Read line. I guess that's the read line. To read the command. Oh, that's nice. So logs this handle and reads a line of input, appending it to the specified buffer. Oh. So I guess we're gonna bind this to guess. Read line, mut guess, and this will be a string. So imperative this. io read line guess, and yeah, interesting. There is no semicolon here at the end. Expect. I think this is the fail case. Expect fail to read line. But it says expect. I guess, yeah, okay. So it's in case, I guess this is some kind of, like type safety. In the sense that some kind of a type safety. Or like a maybe type, I guess. It might work, but in case it doesn't work, it will say fail to read line. Maybe if I put in a number instead of a string. But it says guess, yeah, this is confusing. It says guess the number, and then it, yeah, okay, I'll check with chat what it will say, fail to read line. Okay, and now print line. But you guessed But this is not the program. This is just, yeah, this is not the whole implementation. So you guessed, and now we have a placeholder. And guess. This is familiar from last time. So this should actually work. Guess the number. Please input your guess. You guessed. Let's actually, I'm not sure how Helix shows this. Let's save this and quit. Cargo run. Guess the number. Yes. Please input your guess. I'll do 23. You guessed 23. But why is this string new? Yeah. Curious about something. Why is here like asking for a number and then guess variable has a type string? If I'm reading it correctly, I am coming from Haskell background, so I might be completely off here. You're absolutely correct in observing that the guess variable has a type of string. In Rust user input, let's wait, explanation. In Rust, user input from the standard input standard in is read as a string, so guess is indeed a string. Oh, all right. Well, let's break it down and explain why Rust handles it this way. Here's the code for reference. So let mod guess string new. String new creates a new empty string. In Rust, string is a growable heap allocated data structure for text. Oh, string is a growable heap allocated data structure for text. The mud keyword is used to make guess mutable, allowing it to be modified when we read input into it. This line initializes guess as an empty string to hold the user input. So IO standard in gives access to the standard input. Read line takes a mutable reference to a string and appends the user's input, including the new line to it. It returns a result, which we handle with expect failed to read line to provide an error message if reading fails. Why use string? Rust's standard input standard in reads data as string. Since user input is typically text-based, the readline method appends the input to a string. It is text-based, but you're getting a number. You're asking for a number. I guess you have to convert it then. Converting guess to a number, yeah. If you wanted to use guess as a number, you need to parse it from string to an integer type. Read line, parse the guess to an integer, trimming any white spaces or new lines. Well, is it possible? This is what I'm like, yeah. Let's see what will happen actually. Let's see. So if I run cargo run, guess the number, please input your guess. Let's do 23. You guessed 23. Oh, so it takes this. Let's do cargo run, please input your guess. I won't. You guessed I won't. Guess the number. Please input your guess. It won't. Yeah, you guess. It just, yeah. Removes parse. Why use strings for input? All right. Yeah, I kind of don't like this, but okay. Code that gets a guess from the user and prints it. Well, again, that's just me being uncomfortable still with Rust. This code contains a lot of information. To obtain user input and then print the result as output, we need to bring the I/O input-output library into scope. The I/O library comes from the standard library known as std. Use std.io. By default, connectivity. Oh, yeah, thanks. You know, actually, I just changed my username. All right. I might even make like I don't know, maybe that's too soon to make some kind of a server where I would post the content. Maybe that's actually better. I mean, I don't know, when you add like friends, is that the same thing? Like, I'm just looking what would be better. But thanks really for that comment. Wow, thanks. Oh, okay. Thomasin05 actually just opened the Discord with this nick. I still have to confirm it, actually, my mail, but I'll do it. Thomasin05. All right. Wait a second, Thomasin. I have to. Let me just Thomasin. Yeah, what did I do now? I closed it. Streamlabs. So by default, this code contains a lot of information. So use standard input output. Rus has a set of items defined in the standard library that it brings into the scope of every program called a prelude. It's like in Haskell, and you can see everything in it in the standard library documentation. If a type you want to use isn't in the prelude, you have to bring that type into scope explicitly with a use statement, like a module, I guess. Yeah. Using the standard input output library provides you with a number of useful features, including the ability to accept user input. As you saw in chapter 1, the main function is the entry point into the program. Again, we have this. Fn syntax declares a new function. The parentheses indicate there are no parameters. And the curly bracket starts the body. Yes, this is all clear from before, basically. Printing a prompt stating that the game is requesting input from the user. Storing values with variables. This is new, so we'll create a variable to store the user input. Let mud guess is string new. But wait, if I what's the sum of squares? Yeah, that would be interesting to write sum of squares. Now the program, yeah, I think you can even, hello sir. I think you can, this will be actually much faster. Can you rewrite this as sum of squares and that it asks the input for two numbers, and yeah. I'm not sir, my name is Alberta. Hi Alberta. Hello sir. Oh, I'm sorry, I was reading hello sir, yeah. Well, yes, I'm doing well, thank you. I hope you're doing well too. Thanks for dropping by. Yeah, so Wait a second. Let's see sum of squares with this thing. I think chat can do this. Can you write? No, it can't. Look at this. It stopped. Really? Really? Wait, please go on. Please go on. Yeah, this is interesting. So, right, it's the same thing, right? You see print line sum of squares, prompt for the first number. Please input the first number. And we give the... but now it's trimming and everything. This looks so complicated. This is so simple in Haskell or Lisp. What are you doing, sir? Well, this actually is part of a. You mean like what's this whole stream I'm doing? Yeah. Well, I started to actually follow the tutorial. This thing, build OS with Rust by Phil. Writing an OS in Rust, but kind of the dependencies didn't work. It failed to build, maybe because the tutorial is kind of old a bit. It has just 2 years. It didn't build, but there were some people here and said I should try Rust by example first, right? And then you do Rust by example. Not really, just, having fun. I mean, yeah, you could say I'm working on an open source project, but it's more like just enjoying. So yeah, I wanted to write an OS in Rust, right? To use something very practical, but to build just something and learn the language at the same time. And because I've never done anything in imperative language, so that's why I kind of found this interesting. It's very new to me. So, but then I started with Rust by example, and now I'm basically just doing the Rust book. So now I just started slowly going through the Rust book. What about streaming? I meant, what are your aim regarding to stream? Like, want to continue or just hang around and stop streaming after a while? Yeah, I'll stay around now. Yeah, I'll stay for some time. If you mean like now, continue, just hang around and stop streaming after a while. Well, I stream as I have time, Now it's kind of late-ish, so I'll just stream a bit and then I'll go to bed. Yeah. And then I do every day when I can, I don't stream a lot, I guess. Maybe per day, hour and a half, 2, 3 sometimes, if I have time. So yeah, and then I also send it to YouTube, to my channel. So, all right, but great. Yeah, thanks. Thanks. All right, use standard input. Do you have any schedule? Yeah, no, it's a bit wild because I have a family and job and everything, so it's really hard to plan. Can I see? Yeah, it's the same thing I hear. I think it's just called Domagoiding. Yeah, I just changed it. It's kind of silly. Wait, it's like this? Yeah. Okay. You do understand. I do understand. Yeah. Okay. Yeah, it's this. I used to. I mean, the channel was mostly about NixOS, and I changed the name. I'm on NixOS, so I would only stream, upload stuff about Nix. And now I just changed a bit. What kind of a job you have? No, it's I teach guitar. I play guitar. I studied guitar. I'm a concert guitarist, so to say. Yeah. Thanks. Yeah. So sometimes I put stuff what I play on the guitar here because I'm just trying to find something that will not get a copyright strike. So I use my music. Not because, my music, but it's just, I know I will not get a copyright. Fern of Sigma, this is my Rust friend. Fern Fern was the first on the stream who came, and he's like, he has the eye of the Rust. I thought you read this book. No, I didn't. You thought that I read the whole book? No, I didn't. I'm just going now through it. I thought you read this or you read this book. What do you mean? Guess the number, input your guess. Yeah, no, I didn't. As I said, I thought because, I did Haskell and Nix, I don't have to read this book. Yeah. Didn't you tell me that you looked at this book then gave up? This book? The Rust book? Many books that do imperative languages I would give up. Yeah. Is this your second stream, sir? Second. Very not Sigma of you. Ooh, what does that mean? Sigma. What do you mean by second stream? Not sure what you mean. Let apples 5 immutable, let mud bananas. Guess the number. So storing variables. Let mud guess string new. All right, now the program is getting interesting. So we have this thing. I mean, how long have you been streaming on Twitch? Oh, not long, just like 5 days or something, 6 days. On YouTube for like 6 months. I was on YouTube. I have it for like a little bit longer, as you can see. Yeah, we call the mod like mute. Okay, that's much better than a mud. Okay, yeah, mud. Let mute. Okay. Okay, thanks for the correction. Now the program is getting interesting. Yeah, it's not mute. It's not muttable. Can I follow you on Twitch? Yeah, I guess you can, right? That's great, right? Yeah, sure. Thanks. Now the program is getting interesting, right? The book is written very well for beginners. Yeah, it is. It is. Well, I know that No Starch has this book. Done, is there any alert of follow? Alert of follow? Not sure what that means. I'm pretty new to Twitch, so don't know what that means. Alert of follow. Oh, like, is there any alert? Yeah, I don't know. But yeah, not sure what you mean. This line creates a new variable apples, binds it to value 5 in Rust. Variables are immutable by default, meaning once we give the variable a value, the value won't change. Yeah, we'll be discussing this concept in detail in the variables and mutability. Can I see any pop up or follow you? What do you mean? Like, isn't it like if I just click here on your account and look at this, follow, and there's a heart. Oh, so if I unfollow you, I break your heart. Oh, look at this. It's nice. Yeah, isn't it like that? Can I follow you on Twitch? And now, how do I remove this? Users in chat, my chat. I don't know how to remove this now. Ban. No, I don't want to ban. Warn, whisper, invite. This book is well written. Wait, what is this? Pin this message, click to reply. Wait, okay. Is there any alert to follow? No, I got, yeah. Search alert. Window too small. All right. Window too small. Yeah. All right. To make a variable mutable, we had mute before the variable name. Let apples 5, let mute bananas. You always have to say mute, mute. How many times do you say mute when you work with Rust? Let mute, mute bananas 5. This is the common syntax. Returning to the guessing game program, you now know that let mute guess will introduce a mutable variable named guess. I'm gonna like this. Yeah. What? The mute? No. Returning to the guessing game. All right. Yeah. You know that. Yeah, I was saying just before you came in, there was this book I bought that I haven't read also, The Land of Lisp. The Land of Lisp. Land of Lisp. I bought this book 2011. And the first game in here is the guessing game. The borrow checker and mutability. All these things are going over on your head? What do you mean? On which head? Over on my head? All these things are going over on your head. Not sure what you mean. The borrow checker and mutability semantics. Oh yeah, I was thinking about the, lifetimes. How do you scale lifetimes? It sounds almost like the last abstraction. There is a lifetime. What if you have like many lifetimes? Isn't that like, again, basically an answer you don't, it's pain? Yeah, right. It just sounds like it. That's my, Haskell radar. Like there is a lifetime, like, ooh. Okay, returning to the guessing game. You now know, alerts. Well, leave it, because you're new on Twitch. Oh yeah, alerts. I don't have alerts. You don't want to deal with lifetimes in a single threaded app. Okay. That's another thing when I'm being told you don't want to deal with this, like this kind of like a warning of sorts. That's like so non-functional. Okay, I will return to the. Let me show you an example of alert. A multi-threaded app. All right. Do you have Discord or Instagram? Not yet though. Somebody asked before. I'll just open a Discord because it's the truth of the world. All right, multi-threaded app. All right, I'll just return to the guessing game. You now know that I do have a Discord, but I just opened it. I still have to. I've changed it. Like I have a new nickname for this nickname. Threading is hard. State is even harder. Yeah. Yeah. Returning to the guessing game. Give me your user. It's the same. It's like here. Domagoiding. But I will have to. I have it also on GitHub and this. Yeah. I still haven't actually verified the email. Returning to the guessing game, you know that let mud guess will introduce a mutable variable named guess. The equal sign tells Rust we want to bind something to the variable now. Probably selling assets, I'm guessing. What do you say actually, Firm? Would you say you bind something or you assign something to the variable? That's like an old discussion of sorts. I've heard both. Sometimes you bind something and sometimes you assign something. No, you bind an identifier and you assign something to it. I was like, what do you use in Rust? I use bind. You say bind. You would say I bind, right? Okay. On the right of the equal sign is the value that guess is bound to, which is the result of calling string new. That's funny. In Nix, sometimes I think they mostly use to assign, because not everyone does functional programming, so they use the word to assign, because so that everyone understands. Binding means there's a value contract. Oh, when you say a contract, it sounds like a lifetime. So like it will expire, no? The equal sign tells Rust we want to bind something to the variable. On the right of the equal sign is the value that guess is bound to, which is the result of calling string name. Yeah, also binding, you know what I was confused, not really so confused, but look at this. If I do cargo run, guess the number, please input your guess, and I write, I won't. And it says you guessed I won't, right? Because the guess is this like has a type string, and it asks for a number. So that's the one thing I was like, okay, open Discord and accept my rec. Yeah, I will do it. Okay, I will do it after this, because I still have to verify my mail, and I also always have this I don't know if I saved the password with Discord. Is sometimes weird. Returning to the guessing game. String is a string type provided by the standard library that is Growful UTF. Yeah, UTF-8 encoded bit of text. The new is an associated function, so it's not a type. Is using let or let mute is a binding, because it binds the variable to the appropriate scope. Yeah. It binds the variable. But you bind the variable, but then you assign a value. Okay, you bind a variable and you assign a value. Would you say that? Things like let foo can work. This is a binding. Okay. String is a string type provided by the standard library that is growable UTF-8 encoded bit of text. This thing I read has a type, but indicates that new is an associated function of the string type. How do you read this? How do you read this? The two semicolons. This is a binding, but it won't have a value. Schrödinger's cat. An associated function is a function that's implemented on a type, in this case string. So the new function creates a new empty string. You'll find a new function on many types because it's a common name for a function that makes a new value of some kind. In full scope, what do you mean scope? This new function creates a new empty string. You'll find a new function on many types because it's a common name for a function that makes a new value of some kind. In full, yeah, associated function. Create scope, then module scope, then type, then method. Oh, create scope, module scope, then type, then method. Each going deeper. I get that. All right. But what's in Rust? What's an associated function? Not sure. Look at this sum of squares. It's so long. Like in Lisp, this is like one line. Okay. This is so slow. Associated function. And function takes self, mute self. It's called a method. Oh. what is it? Just a fancy Haskellized ass name for method. Associated function is a function that is defined within a block of type that does not take self as parameter. This means it's associated with the type itself rather than with specific instance of the type. Okay. Method takes the instance of type. Okay, yeah. Associated function are called using the type's name rather than an instance. They're often used for constructors, type constructors, or utility functions related to the type. Let empty string new. New is an associated function of string. Print line, this is an empty string. Okay, in full. Let's go on because I'm kind of doing the rabbit hole thing. The let mute guess string new line has created a mutable variable that is currently bound to a new empty instance of a string. Woohoo! If you know Python. No, I don't know Python. In full, no, yeah. Receiving user input. Recall that we included the input-output functionality from the standard library. Standard input-output, yeah. On the first line of the program, now we'll call the standard in function from the IO module, which will allow us to handle user input. Well, this first part of the program is not really difficult. I mean, this is just, but that's just the first half. If we hadn't imported the IO library with use standard IO at the beginning, we could still use the function by writing this function call as standard IO, standard input. Returns, the standard in function returns an instance of this, which is a type that represents a handle to the standard input for your terminal. Next, the line read line mute. Now I have to correct myself, always mute guess. Calls the read line method on the standard input handle to get input from the user. Can you try my NeoVim config for Rust? Yeah, I could try your NeoVim, but I don't have NeoVim now installed. I don't have it installed. You know, it would be fun to try it. You could send me that. I don't know how, I guess, or I could just copy it somewhere and try it out. Next, the read line calls the read line method on the standard input handle to get input from the user. We're also passing, yeah, I bet. We're also passing mute guess as the argument to the read line to tell it what string to store the user input. The full job of read line is to take whatever the user types into standard input and append that into a string without overwriting its contents. So we therefore pass that string as an argument. The string argument needs to be mutable so the method can change the string's content. There's a lot of words in this book. Like that's just my style. I would like more code in between. It's a lot of explanations. Whenever I read an explanations, it's like I have to pause, and then, yeah. This indicates that this argument is a reference. Like I like what Sylvan does when he does Nix. He does a lot of wrong things so that you look how the compiler behaves. And then you correct things, and then you add things from zero. You build stuff up, but I guess that's more real time. It's hard with a book. It's hard to write a good book. This indicates that this argument is a reference, which gives you a way 0 to 100 guide. Yeah. They really have to do it. They do have that. What do you mean they do have that? Multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. References are a complex feature, and one of Rasta's major advantages is how safe and easy it is to use references. You don't need to know a lot of those details to finish this program. For now, yeah, all you need to know is that like variables, they show code that could work in theory, but doesn't. Yeah, that's important. For now, all you need to know is that you don't need to know, okay. Chapter 4 will explain references. Handling potential failure with result. This is like a maybe, right? Like a maybe. We are still working on this line of code. We are now discussing a third line of text. But note that it's still part of a single logical line of code. This next part is this method. So it's called a method. Oh yeah, you said it's a method. Expect read line. Also this dot here. Fail to read line. We could have written this code as standard in read line mute guess expect fail to read line. However, one long line is difficult to read, so it's best to divide it. It's often wise to introduce a new line and other white space to help break up long lines when you call a method with method name syntax. Oh, alright. Let me check out your Vim. Alright. Init Lua. I guess it's init Lua. Ah, you're doing it all in Lua. Okay. Oh, wait. Well, that's short. Or you have it in... Wait a second, you have configuration modules. Oh, nice. I see. Options. Use 4 spaces. Display signs. It's nice. It looks very neat. Very, FTP plugin. TypeScript, JavaScript. Keymax specs. What do you have in the specs? Tree sitter. Telescope, Lua line, comment. Oh, this is nice. You have a buffer line. Buffer line. What do you have in Vim Web? Dev icons. Probably looks nice. Yeah. Okay. I'll check it out. I'm not sure how to wire this into Nix. I guess I don't have to actually. I can just clone this. And Vim can, do it. Not sure. I don't have any more. Maybe if I go, I had a very simple NeoVim. Check plugins, Lua. It's not working. Plugins, Lua. Do I have to do like... Not sure. The link didn't work. Oh, I mean in the Lua folder. Plugins Lua. Oh, this. Yeah. Lazy, you have this NeoVim. Okay, installing plugins. Branch table, lazy path. Require disable plugins. Yeah, nice. I still think I'm gonna try again and switch to Emacs because it's my it's my old love. But I haven't used it in a couple of years, so I'm now really... Yeah, let's get back to this. So this is, it's nice that it has this, right? Try NeoVim. Yeah, I did try NeoVim. I did try. Um, yeah, with Vim actually, and with Helix, I like the way that you change. You know that you have modes. It's nice. I think it's good for your hands also, because you don't have to hold things. You don't have to hold things down like the control, but you just change. It's almost like you have layers. So you shift and then you type again. So in that sense, your hands are, I think it's actually better for your hands than when you hold like the control down, because you have to understand how the editor work flows. Yeah, it's time consuming, but it's fine, right? I mean, when you get it, you get it. It's okay. You do document things. We would have written this code as, okay, one long line is difficult to read, best to divide it. Enumeration, enums. Enums, I'm like, I think these are sum types. As mentioned earlier, readline puts whatever the user enters into the string we pass it, but it also returns a result value. Result is an enumeration, often called an enum, which is a type that can be in one of multiple possible states. We call each possible state a variant. Yeah, I know that from Haskell at least, the sum types. But these are just different names, and each possible state is a variant. Chapter 6 will cover enums. The purpose of these result types. Where's the result? Our peak data design bliss. Yeah, Rust enums. Okay, that sounds like a peak data design bliss. That's a nice sentence. Values of the result type, like values of any type, have methods defined on them. An instance of result has an expect method that you can call. If this instance of result is an error value, expect will cause the program to crash and display the message that you passed as an argument to expect. If the readline method returns an error, it would likely be the result of an error coming from the underlying operating system. If this instance of result is an okay, expect will take the return value that is okay, holding and return just that value so you can use it. In this case, that value is the number of bytes in the user's input. I still think these are a lot of words, but it's a different kind of a language than Haskell, That's why I said, like, you spent a couple of years. I know you said it's, yeah, I can understand this, but it's a different language. It's a burrito. Yeah. No, but it's kind of a different language. I think that's also hard for people when they learn something. If the read line return here, what I see a lot, yeah, from inside. Here, what I see a lot is these things that this returns, this will be, this goes here, this is the value. Take the return, take the value, pass the value. This is, yeah. If you don't call expect, the program will compile, but you'll get a warning. Cargo build. But we still don't have this. Wait a second. Fail to read the line. That's called unwrapping. Yeah. We could have written this code as expect fail to read line. If you don't call expect, the program will compile, but you get a warning. Cargo build. Rust warns that you haven't used the result value returned from readline, indicating that the program hasn't handled a possible error. So you've read this whole book. The right way to suppress the warning is to actually write error handling code. But in our case, we just want to crash this program Oh, you did. When a problem occurs, so we can expect. You learn about recovering from errors in chapter 9. Printing values with print line placeholders. Yeah, okay, we know this. Aside from the closing curly brackets, there's only one more line to discuss in the code so far. So this, of course I have. It's necessary to use Rust. Yeah, of course I have. This line prints the string that now contains the user's input. The curly brackets is a placeholder. Think of curly as a little crab pincers that hold a value in place. It's like teaching Rust to a 4-year-old, like it's like a little crab. When printing the result of evaluating, no, it's like when I teach guitar, I would, uh, these days I don't, but I used to teach guitar to 4-year-olds. And if you have to tell them to grab the neck and hold it, you would tell them to grab it, I don't know, like a dog, and like a dog would grab the neck, so that they get the idea of a dog grabbing something, and that makes their mind grab the guitar stronger than if you just say press the board, press the fretboard, so it works. Same as here. Curly brackets as little crab pincers that hold a value, and now your mind is like, aha, holding a value. You do what? I teach guitar. Yeah, I teach guitar and I play guitar and I studied guitar and I'm a guitarist. Yeah, I can't music, but man, I like guitarists. Well, I'm a guitarist. Yeah, my whole life. Yeah. Well, the stuff what I was putting before, actually, if you remember, there was a like a guitar. That was me, because as I said, sometimes I would get like a copyright strike. So if I put my stuff, I won't get it. Yeah. Yeah. Anyway, this line prints the string that now contains the user's input. The curly brackets is a placeholder. Yes, when printing the result of evaluating expression, place empty curly brackets in the format string, then follow the format string with a comma-separated list of expressions to print in each empty curly bracket placeholder in the same order. Yeah, thanks. Printing a variable and the result of an expression is one call to print line. Would look like this. Oh yeah? Get struck by their own voice, or sometimes even silence. Well, then yeah, I could be, because I could be struck because I have two channels. I have one where I have my own stuff, where I put guitar, and the other is where I put the Nick stuff and the programming. So I might get a strike from the second channel. Okay, let x is 5, let y is 10. Print line, that's not the thing. Copyright trolls, oh yeah. Oh, yeah, not sure how that works. Print line, x and y is +2, y +2. What does this print? Yeah, suing themselves. They tried it. X is 5 and y +2 is 12. X is x and y +2 is y +2. Let x is 5. Yeah, but there's not, yeah. It would be nice to have a book like learn, what's the name? Haskell for Good? What's the name of the book? So here, this book, you type really a lot. You just type and type. and he talks a bit, and then you type and type and type. I really like this approach because you feel like you're doing something. Yeah, the MC law. Let y print line, x is x and y plus 2, y plus 2. So I guess it will be same. Wait, print line, you guessed. What happened with the guessing number? Wait, let's quit this. This is the guessing game. This is more valid. Where am I now? Wait a second. Oh, I'm in the source. Yeah, I'm doing this with cargo, with the guessing game. No, okay, I'm gonna get back to the guessing game. See what happened with the guessing name. Yes, it worked. Right. Cargo run. Input your guess 21. You guessed 21. Even though I'm curious what to do, you see, if I write like hamburger, you guessed hamburger. Yeah. At this point, the first part of the game is done. We're getting input from the keyboard and then printing it. Generating a secret number. Next, we need to generate a secret number that the user will try to guess. Ah, yeah, that's the second step, right? The secret number. Why is it called a secret number? Oh, it's the secret number. We need to generate a secret number that the user will try to guess. To generate a number that the user will try to guess, but it's written as secret number. Yeah. Use a dependency. Next step, use a dependency. The secret number should be different every time, so the game is fun to play more than once. We'll use a random number between 1 and 100, so the game isn't too difficult. Rust doesn't yet include random number functionality in its standard library. It doesn't. I really want to see what was the land of Lisp. Wait a second. That would be nice. Land of Lisp. There was random Land of Lisp, generating random numbers. Chapter 10. Come on, is this thing open? Land of Lisp. Generating certain range. No. Land of Lisp random generator. No, guessing game. Source code. Land of Lisp. I want to see what they did. Guess Lisp. Yeah. Look at Lisp thing. So small 1, big was 100. Yeah. Guess my number. Ash. Ash is a function, some sort of. Yeah, you're right. It's also some kind of a function. Plus small and big. Minus 1. Smaller. So this sets like a variable. Big is what? 1 minus. It's not 1 minus. I forgot this. 1. Guess my number. Guess my number. Bigger. Small. Define. Start over. It uses the ash. Forgot what's the ash function. Yeah, just interesting to compare these two codes. It's the same program though. Really? Well, you just have to unwrap it from inside, you know. Yeah, actually, you do have to wrap it from inside and then you go outside. Yeah, kind of psychotic. Yeah. So we need to generate a secret number that the user will try to guess. The secret number should be different every time, so the game is fun to play more than once. We'll use a random number between 1 and 100, so the game isn't too difficult. Rust doesn't yet include a random number functionality, right? So a crate. Using a crate to get more functionality. Remember that a crate is a collection of Rust source code files. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate, which contains code that is intended to be used in other programs and can be executed on its own. Cargo's coordination of external crates is where Cargo really shines. Before we can write code that uses rand, we need to modify the Cargo toml file to include the rand crate as dependencies. So we need to what? We need to go hx cargo toml and declare dependency. Already a dependency. Rand. So this has to be updated also, I guess, 0.8.5. In the Cargo toml, everything that follows a header is part of that section that continues until another section starts. You can do that. There is a cooler way. Create your project. We specify the rand crate with semantic like cargo add rand. Oh, I see. So I see. So you're saying like if I do like this, cargo add rand. Locking 15 packages. Why did it add like features? Oh, okay, adding rand. So now if I show cargo toml dependencies rand, yeah, nice. Cargo add rand. All right, everything that follows a header is a part of that section that continues until another section starts. In dependencies, you tell cargo which external crates your project depends. Semantic versioning. Any version that is at least 0.85 but below 0.90. Okay. Cargo considers these versions to have public APIs compatible with version. Okay, let's build a project. Cargo build. Okay, cargo add check. Which repository? So what do I have now? I still don't have nothing, right? We didn't really add the source code. You see, this was a lot of text, but well, it's interesting how the book is written. Shorthand, cargo B. Cargo B. You may see different versions, crates.io. Okay, make a trivial change and then save it and then build it again. You only see 2 lines of output. Alright, ensuring reproducible builds with the cargo log file. Cargo. Cargo has a mechanism. Cargo will use cargo. Cargo B is a cargo build. Less characters. Yeah. Rust creates the cargo log for the first time we run cargo build, so we now have this in the guessing game directory. What's in the cargo log? Package. Package. libc, look at this. Quote. Oh. Okay, updating a crate to get a new version. Now we are... What happened with the guessing game? When you do want to update a crate, Cargo provides the command update. Reproducible build. Are you talking about Nix? Which will ignore the cargo log. We do log files. Yeah. Cargo will then write those versions to cargo log file. Cargo will only look for versions greater than 0.85 and less than 0.90. I guess these log files were the inspiration maybe for Flake log files. I think Flakes, I don't use Flakes. Not now at least. But they do have a log file also where you can pin the versions down. Cargo will only look for versions greater than 0.85 and less than 0.90 if the RAN crate has released the 2 new versions. Log files are an old concept. Well, yeah, it does sound like it. Log file. Cargo will only look for versions greater than 0.85. Cargo update. Cargo. I'm kind of skipping a bit here. I want to get back to this generating a random number. Let's start using RAN to generate a number to guess. The next step is to update source main RS as shown is in listing 2.3. Yeah. And the comment is below. Yeah, I would... yeah, okay. This is just me again. Where am I now? Did I move away? Okay, let's do hx source main rs. Use standard IO. Use rand. Okay, now we're going to use the dependency, I guess. rng. And f and print guess the number. Please input your guess. Oh wait, the program now works differently. Wait. Print line guess the number. Oh. Yeah, I'm confused now. Like, what do you mean guess the number? The secret number is secret number. I get the program how it works, but this, in a sense, it's kind of confusing. Look at this. First, we add the line use this rand, right? Okay, that's clear. Now the RNG trait defines methods that random number generators implement, and this trait must be in scope. Yeah, read. And this trait must be in scope for us to use those methods. Chapter 10 will cover traits in detail. We're adding 2 lines in the middle. In the first line, we call the rand thread RNG function. Yeah, we call it here. That gives us the particular random number generator we're going to use. One that is local to the current thread of execution and is seeded by the operating system. Yeah, that makes sense. Then we called the genRange method on the random number generator. This method is defined by the RNG trait that we brought into scope with the use rand RNG statement. The genRange method takes a range expression as an argument and generates a random number in the range. The The kind of range expression we're using here takes the form start, end, and it's inclusive on the lower and upper bounds, so we need to specify 1 to 100 to request a number between 1 and 100. Yeah. Print guess the number. Let secret number. So what do we have? What do you got to do? So let secret number rand thread RNG generate range. Okay, well, that's clear. You know what's the confusing part to me? It's this guess the number. Oh, so it's gonna generate it. And then please input your guess. Yeah, I'd have to see it at the end, then I will. Please input your guess. The secret number is secret number. Range expressions. AB is from A to B. AB from A up to and including B. Yeah. Yeah. Okay. That makes sense. Yeah. Let's secret number. So print line the secret number is, and we have the placeholder secret number. No, we should not put this. Yeah. The secret number is secret number. So if we run this cargo run, could not compile guessing game, use rand RNG, import paths are delimited using help use double colon. Rand thread RNG. Ah, look at this. Guess the number. The secret number is 61. Please input your guess. 61. You guessed 61. Wonderful. The secret number is 61. Please input your guess. So if we run it again, the secret number is 10. Please input your guess. 10. You guessed 10. Guess the number. It's just weird. Okay, I know I have to read the whole thing and understand it, but so far it's kind of guess the number. Yeah, okay. This is the same. Now if we look at the source code here, yeah, it's all the same. So adding code to generate a random number. So first we add the line use rand. That's what we read, right? So we are adding two lines in the middle, right? In the first line we call the rand thread RNG. It's teaching you multiple concepts at once, slowly. Yeah. The RNG trait defines methods that random number generators implement, and this trait must be. It is, but it's very slow. It's slow in the sense of, you know, you just, yeah. The RNG trait defines methods that random number generators implement. Yeah, I can see why this would be hard for someone coming from, Python or or like ja- ja- JavaScript. This would be a, but it's interesting. I thought like the book, okay, I guess that's the book, but why would, maybe it's supposed to be like this, yeah. I guess if I don't know if I would teach this, I would maybe I would maybe not put so much at once, and maybe just increase the speed just a little bit. You increase the speed just a little bit. This is a very slow. First we add the line use rand, and then he says chapter 10 will cover this in detail. This book is for absolute beginners in Rust, but not in programming. Yes, that's true also. But still, even if, yeah, well. Next, we're adding 2 lines in the middle. In the first line, we call the rand. You're right. This book is not for someone who is, learning how to program. We call the rand thread RNG function that gives us the particular. Yeah, I know the slow ride, right? I mean, I've been trying to learn also functional programming for way too long. It's like a Tarantino movie, it gets crazy at the end. Okay. I just saw Joker, the new one. Really nice. Really nice. Very sad also. Very sad. Very sad. In the first line, we call the rand thread RG function that gives us the particular random number generator we're going to use, one that is local to the current thread of execution that is seeded by the operating system. Then we call the genRange method on the random number generator. Well, this is clear actually, but even though it's explaining a lot what it means, this method is defined start 1 up to 100, inclusive on the lower and upper bounds. So we need to specify. This is, well, it's clear, but it's more it seems like more information that I need, a little bit more. I guess I would have to write the whole thing, every piece. Yes. Yeah, I still think it's a lot at once. But again, this book is new to me. For me, it's kinda a little bit on the too much side. Not that it's yeah, it's a little bit on the too much side, because it starts, very, yeah. The kind of range expression we're using here, even this first example of the guessing game, it's very slow. The language is not intuitive in the common sense. You won't just know which traits to use and which methods and functions to call from a crate. So each crate has documentation with instructions for using it. Another neat feature of Cargo is that running the Cargo doc, but it mentions like a lot of the times the cargo, or okay, this is a note. If you're interested in other functionality in the RAND crate, for example, run cargo doc, open and click RAND in the sidebar on the left. I like about the book because there should be like a chat GPT of the book itself. What I sometimes do with chat GPT is I copy the entire thing. I copy the entire thing into the chat GPT and I talk with the chat. No, never. Yeah, but it will be very helpful also, you know. And then I paste in the whole thing, and it's kind of helpful also to me. The second new line prints the secret number. This is useful while we are developing the program to be able to test it, but we'll delete it from the final version. Like now, yes, but look, I have no idea about this now. This thing I understood, and I've written kind of similar lines of this, and I understand what this does, but I still don't remember what I read here. This, I don't remember. Let's read it again. We're adding two lines in the middle. The first line we call the ran_thread RNG function that give us the particular random number, okay, that we're going to use, and one that is local to the current thread of execution and is seeded by the operating system. That makes sense. But then we call the genZRange method on the random number generator. Can you explain your code? Yeah, but still, no, I cannot explain. I mean, I know what this line does, but I cannot explain it like this. Then we call the genRange method. Explain like I don't know Rust. That's the best test. Yeah, I can't. Yeah, I'm no programmer then. This method is defined by the RNG trait that we brought into scope with the use rand RNG statement. The genRange method takes a range expression as an argument and generates a random number in the range. The kind of range expression we're using here takes the form start end, and it's inclusive on the lower and upper bounds. Okay, he's just going into a lot of details here, but this is not too abstract. All right, he's not doing it. This is still okay. This is just the basic, the first level of abstraction. He's not going to second, third, or like any fourth level. So this isn't complicated. It looks like it, but it's not. Imperative programming. What do you mean? The second new line prints the secret number. This is useful while we are developing the program to be able to test it, but we'll delete it from the final version. It's not much of a game if the program prints the answer as soon as it starts. Try running the program a few times. Yeah, secret number is 7. You guessed 4. 83, guess 5. Great job. Now comparing the guess to the secret number, you need this type of explanation for novel syntax. You do, but I also think okay, I think someone would also, you know, argue about that, like the way how you introduce it, depending. Crab width means code that doesn't build. Oh, okay, nice, thanks. Now that we have user input and random number, we can compare them. That step is shown in listing 2.4. Note that this code won't compile just yet, as we will explain. All right. I like their approach. They are very, you could say slow, but you could also say gentle, you know. Sometimes with functional programming books, they are very they're not gentle. They seem gentle, but it just goes, you know, like you presume a lot. And with this book, I like it that they don't presume so much, but they like really go in details. Use RAND, use standard CMP ordering, use standard IO. Function main, okay? Print line, you guessed, guess. Yeah, that's what I like about it, yeah. And also with functional programming, they like to use like, look, if you do this, it's really simple, and that's really simple. It's like almost sometimes they are like, it's very simple. You do this and this, and it's simple. It's just that. It's like math, you know. You just do that, and it's simple. Well, it's not so simple. I can't run this. Yeah, it won't run. But what is this now? Isn't that match statement so elegant? Yes, let's see the match statement. Match, guess CMP secret number, ordering less. It is elegant, but it's still a lot of typing, right? It's like a switch, but you have to handle every case. Yeah, that's like in Haskell, right? Well, that's like in Haskell, right? That's like when you make your own types. Yeah. Match, guess CMP secret number, ordering less, print line too small. That's the land of Lisp, right? Smaller. Define smaller, bigger, smaller and bigger. Verbosity is preferred over brevity in this household. Sometimes it's actually, you're right, because sometimes the mistakes, in communication, they happen because you're too brief, and we don't read our minds, and you're brief, and the people don't understand, and then you could have a problem, right? So it's sometimes, but sometimes people are too verbose, yes. And it's good to be wise and know the balance, I guess. Match, guess CMP secret number. Ordering less, print line too small. Ordering greater, print line too big. Or ordering equal, print line you win. First we add another use statement or ordering. But I would have to add this. I should type this thing. You don't need brevity in a compiled language either way. Yeah, I was thinking like the way you type things, I guess. Maybe like these things, like these braces or the commas, I think you can like use this also in Haskell with the braces, the curly brackets and the commas, and there is a way how you can, because in Haskell you have like the indent rules. I don't know if it's in Rust like that, right? It would be nice like if you, but yeah, wait, I should really type this. So we have use rand RNG and use standard IO. But why is the RNG? Oh, it's a capital RNG. Commas mean fields or cases. Yeah, they're very good visual markers. Yeah. visual marker. Yeah, that's a good word. Use std. Use std cmp or ordering. Lowercase name means it's a module or a function. Capitalized means type or trait. Lowercase name, a module or function. Capitalized means, yeah. So how is our game doing? Guess the name. fn main snip. You guessed. Please input your guess. You guess. So it's here. You guessed. Print line. Oh, match. We have match. Guess cmp. This method returns an ordering between self and other. By convention, returns the ordering matching the expression. Examples. Oh, it's giving that as an example. Assert. Right, let's do it again. That's the convention. Secret number. Guest CMP. Ordering less and print line too small. No, we don't need this. Or ordering greater. Also again, print line too big. Typo. And ordering less, greater, or equal. Print line you win. Is it this? No, it's not. Comma. So less, greater, or equal. What does land of Lisp has? Smaller, bigger. Start over. It doesn't have. You guessed. Ordering. Yeah. Wow. So this will not work. So first we add another use statement. Bringing a type called standard CMP ordering into scope from the standard library. Standard IO buff read is a trait in Pascal case. Standard fs read to string is a function. Oh yeah, okay. The ordering type is another enum and has the variance less, greater, and equal. These are the three outcomes that are possible when you compare two values. Yes. Then we add 5 new lines at the bottom that use the ordering type. The CMP method compares two values and can be called on anything that can be compared. It takes a reference to whatever you want to compare with. Here it's comparing guess to a secret number. Then it returns a variant of the ordering enum we brought into scope with the use statement. We use a match expression to decide what to do next based on which variant of ordering was returned from the call to CMP with the values in guess and secret number. So a match expression is made up of arms. Arms? An arm consists of a pattern to match against, pattern matching, and the code that should be run if the value given to match fits that arm's pattern. Rust takes the value given to match and looks through each arm's pattern in turn. Patterns in the match construct are powerful Rust features. They let you express a variety of situations your code might encounter, and they make sure you handle them all. These features will be covered in details 6 and 18. You can represent state or anything else with enums like this and force the user or yourself to handle it. Yeah, I'm kind of familiar with that from Haskell. That's almost like the first thing you learn. That's like the first thing you learn in Haskell. One of the first things. Like sum types, basically. Enums are sum types. Like a maybe. Maybe is also like a basic sum types. Either it works or maybe it doesn't. Yeah. Let's walk through an example with the match expression we use here. Say that the user has guessed 50 and the randomly generated secret number this type is 38. But I guess Rust only has maybe is an option T in Rust. Oh, okay. Okay. Option T. Let's walk through an example with the match expression we use here. Say that the user has guessed 50 and the randomly generated secret number this time is 38. Enum with variants, okay, T and none. Wow. Yeah, today I was, yeah, okay, interesting. When the code compares 50 to 38, not okay. Sum T, not okay. When the code sum and none. When the code compares 50 to 38, the CMP method will return ordering greater because 50 is greater than 38. I see. Ordering less, ordering greater, ordering equal. But it's interesting you're not implementing it. Or ordering greater. It's like, yeah, it's abstracted. Right? You are expressing it. Yeah, but it's not like in the Lisp case where memory allocation API. You're expressing it. Yeah. Guessing game. I was just wondering how would that look like in Haskell guessing game. Guess a random number. Simple. Bad gateway. I really want to future learn, write a guessing game. Players guess, secret word, current display. If no, that's not right. Maybe this. Oh, I don't like this code. Random number, look at this. Also import system random. But try to guess the secret. 1 to 100, play secret. If this, else if. Yeah, I don't like this code. Wait, I don't. Oh, look at this. An assisted random number. An assisted random number guessing game. Gen secret int, IO int, gen secret max do secret random, return secret, limit 100. Get guess low high, guess between, show low. Next turn. Oh, everything's declared here. Guess, turn secret. Guess is less than low, greater than high. Think about it. Too high, too low. Oh. Yeah, I wonder how this too small, too big. Wasted guess. Think about it. This is a little bit different, yeah. This will take a while, I can see. Even this, guessing game. But it's cool. Handling the possible return values of comparing two numbers. We did here ARM. Let's walk through an example with a match. When the code compares 50 to 38, the CMP method will return ordering greater because 50 is greater than 38. The match expression gets the ordering greater and starts checking each arm's pattern. It looks at the first arm's pattern or ordering less and sees that the value ordering greater does not match or ordering less. So it ignores the code in that arm and moves to the next arm. That makes sense. It's kind of weird to use arm, the term arm. The next arm's pattern is ordering greater. This is just for me, which does match ordering greater. The associated code in that arm will execute and print too big to the screen. Let's try it. It's a road term, I guess. It's a road term. Like roundabout arm. Roundabout arm. Yeah, it's just a bit, like the first arm, the second arm, like a roundabout arm. A roundabout arm. Mismatch types. Could not find. What did I write? I misplaced. Aha. STD. What did I write? This was wrong. CMP. CCMP? CMP. Expected string found integer. Expected reference string found reference integer. Well, that's nice. For more information, try rustc explain. All right. I think I will have to. What's the time? Yeah. I'll have to go soon, bedtime. So it was great. And it's a really slow start, but I kind of like it. And really thanks for the help and for dropping by. So good night. Good night. All right. Bye-bye. I have to write. Someone said, did I write that down? Fern Sigma. I did write it. Okay. Yeah, you too. All right.